What if I told you that a tiny frozen world, sitting 4 billion miles away from the sun, is somehow keeping itself even colder than the empty space around it? A place so small, so distant, so forgotten by most people that nobody expected it to be doing anything at all. And yet, the James Webb Space Telescope just caught it in the act of something scientists still cannot fully explain. Before we go any deeper into this, do me one quick favor. If you enjoy space stories told the honest way, without clickbait and without noise, tap that like button, hit subscribe, and share this video with someone who still misses Pluto being called a planet. It costs you nothing, and it truly helps this channel keep telling stories like this one. Now let's rewind, because to understand why this new discovery is such a shock, you have to know how quietly Pluto entered our lives in the first place. The year was 1930. A young man named Clyde Tombaugh, only 24 years old, was sitting inside a small observatory in Flagstaff, Arizona. His job was almost painfully boring. He would photograph the same tiny slice of the night sky on 2 different nights, then compare the 2 images by flipping back and forth between them. He was looking for one thing and one thing only, a single dot of light that had moved. Most of the time, nothing happened. Star after star sat frozen in place. But one cold February evening, something on his photographic plate shifted. A pinpoint of light, so small it could have been ignored, had crawled a tiny distance across the sky. That little dot was Pluto. And with that one movement, the solar system suddenly had a 9th member. For the next 76 years, Pluto proudly held that title. Kids drew it on posters. Textbooks named it. Songs remembered it. It became part of how humans imagined our little corner of space. But then, in 2006, something painful happened. The International Astronomical Union sat down, took a vote, and stripped Pluto of its planet status. Just like that, it was demoted to a dwarf planet. Pluto is still the only world in history that was discovered, celebrated, and then officially voted out of the very club that made it famous. For most people, that moment felt like the end of the story. Pluto became the punchline, the underdog, the tiny loser at the edge of the solar system. But here is the thing. That assumption was wrong. Very wrong. And the more we looked, the more Pluto refused to stay quiet. Let me pause here for a second, because it is honestly wild how little we knew about Pluto for most of the 20th century. Even the biggest, most powerful telescopes on Earth could only show it as a blurry smear of light. Astronomers could track where it was going, sure. That part is just math, but its size, its color, its surface, whether it even had an atmosphere, complete mystery. In fact, for decades, scientists thought Pluto had to be much bigger than it actually is. That belief came from what they thought were tiny gravitational tugs on Neptune and Uranus. Turns out, those tugs were just measurement errors, not real. So a lot of what people believed about Pluto for generations was basically a guess sitting on top of another guess sitting on top of yet another guess. Which is why what happened next in the summer of 2015 hit the science world like a lightning bolt. After a journey of 9.5 years and more than 3 billion miles, NASA's New Horizons spacecraft finally reached Pluto. It was flying at over 30,000 miles per hour. That is not a typo. It could not slow down. It could not stop. It could not turn around and take a second look. It had one shot, a few precious minutes. That was it. And what it sent back completely broke the old picture of Pluto forever. There was a massive, pale, heart-shaped plane stretched across the surface, smooth and eerily young-looking, sitting right next to ancient, cratered wastelands, mountains made of solid water ice, taller than 10,000 feet, punched up into a thin, hazy sky. At those brutal temperatures, water ice does not slip and slide like it does on Earth. It becomes as hard as granite. Frozen nitrogen was slowly churning like a giant lava lamp, hinting that something warm was moving underneath. And rising hundreds of miles above the surface were layers of soft blue haze glowing in the sunlight. Pluto did not look like a dead rock. It looked like a world that was still becoming something. But then, New Horizons was gone, flying deeper into the dark. It had done its job, and it kept going. Everything it missed on that one flyby was going to stay a mystery. For years, scientists argued, built models, and made guesses they had no way to test. They did not need another photograph. They needed something completely different. They needed a way to actually read Pluto's chemistry from millions of miles away, without ever sending another spacecraft. And that is exactly where James Webb came in, because Webb does not work like New Horizons. Webb does not fly past things. It does not snap pretty pictures. Webb reads the light itself. It splits sunlight into its individual wavelengths, and each of those wavelengths carries a fingerprint, a chemical signature, a story about what is really out there. Even when the target is just a tiny pinprick of reflected light billions of miles away, Webb can tell scientists what molecules are floating around, how warm each layer of the atmosphere is, and how that atmosphere is behaving over time, all without moving an inch. Now here's the technical part that used to drive astronomers crazy. Pluto has a giant moon called Charon, and from Earth's point of view, or from any telescope near Earth, Pluto and Charon sit so close together that older telescopes could not tell them apart. Their heat signals blurred into each other. Every time a scientist tried to measure Pluto's atmosphere alone, Charon's heat leaked into the reading. It was like trying to hear one person whisper while another person shouted right next to them. Webb solved that with its huge golden mirror and its incredibly sensitive infrared eyes. It could finally separate the two. Pluto's own heartbeat, its own thermal glow, could finally be measured on its own. And starting in 2022, once Webb was fully calibrated and ready, it turned toward Pluto for the very first time. What came back was not just a clearer image. It was a full diagnosis of a patient nobody had ever properly examined before. And some of the results were so strange, researchers are still arguing about what they actually mean. Quick pause here, because I want to say something, honestly. If you have made it this far into the story, you are already the kind of person who cares about the truth more than the hype. That is rare. So if you have not already, smash that like button and drop a comment with the word Pluto, so I know you are still with me. It genuinely helps the algorithm push this video to more curious minds like yours. Now let's keep going, because the first big Webb discovery is honestly hard to wrap your head around. Remember that blue haze New Horizons, photographed back in 2015? For years, scientists knew Pluto's thin atmosphere was wrapped in a soft veil of hydrocarbon particles. What they did not know was what that veil was actually doing to the world underneath. Back in 2017, a planetary scientist named Shi Zhang at the University of California, Santa Cruz, proposed an idea that sounded almost upside down. Everyone knew that on Saturn's moon, Titan, atmospheric haze traps warmth. It works like a blanket. Zhang looked at Pluto and said, wait, what if Pluto's haze is doing the exact opposite? What if it soaks up sunlight during the day and then throws that energy back out into space so fast that Pluto's thin air cannot hold on to any of it? In other words, what if the haze is not a blanket at all? What if it is a radiator, a cooling system, a tiny built-in refrigerator hovering above a world that is already almost frozen solid? At the time, that idea sounded a bit wild. There was no telescope that could actually test it. Then Webb came online, and Zhang finally had his answer. A team, led by astronomer Tanguy Bertrand at the Paris Observatory, used Webb's mid-infrared instrument to measure Pluto's atmosphere directly. The results were published in the journal Nature Astronomy in June 2025. And guess what? Zhang was right. Pluto's upper atmosphere really is being actively cooled by its own haze particles. The measurement came in about 30 degrees Fahrenheit colder than earlier models had predicted. Let that sit for a second. Pluto is not just cold because it is far from the sun. Pluto is running its own refrigerator. It is actively cooling itself down. And scientists are calling this a completely new kind of climate, a climate we have never seen anywhere else in the solar system. This is not just a fun fact. This might change how we understand hazy worlds in general. It might explain what is happening on Neptune's moon Triton. It might even give us hints about what Earth's own sky looked like billions of years ago, long before oxygen filled the air. One tiny dwarf planet just opened up a door we did not even know was there. There is a second Webb discovery that is quieter, but honestly just as weird. Even the faint trickle of sunlight that reaches Pluto is enough to do something extraordinary. That weak sunlight actually breaks methane molecules apart high up in the sky. Those broken pieces do not disappear. They stick together. They form heavier chemicals. And those heavier chemicals eventually become reddish-brown particles called tholins. The tholins slowly drift down like the world's saddest, slowest snowfall, landing on Pluto's surface. New Horizons already caught early signs of this back in 2015, and Webb has been refining the story ever since. Here's the part that always stops people cold. Tholins belong to the same family of organic molecules that some scientists believe rained down on the young Earth. The same kind of raw building blocks that may have helped kick off the chemistry that eventually became life. On Pluto, this exact same process has been running quietly for about 4 billion years. Every single day, a soft, endless drizzle of pre-life ingredients falling onto a surface that is simply too cold, too frozen, and too dead for any of it to ever spark into anything alive. To really feel how cold we are talking about, look at the numbers. Sunlight on Pluto is roughly 1,000 times fainter than sunlight on Earth. Even the brightest hour of the day there would feel like a heavy twilight here. Surface temperatures sit somewhere between negative 387 and negative 369 degrees Fahrenheit. That is more than 250 degrees colder than the coldest temperature ever recorded anywhere on our planet. At that kind of cold, nitrogen, the same gas making up most of the air you're breathing right now, freezes solid. If you took the atmosphere you are standing in and dropped it on Pluto, it would just fall to the ground as ice. This is why the tholin discovery matters so much. Scientists have argued for decades about where the first organic building blocks on Earth came from. Did they form here? Did they come from space? Did they drift down from icy environments similar to Pluto's? Nobody knows for sure. But Pluto gives us something priceless, a live working laboratory of that chemistry. A process still running right now that on Earth ended billions of years ago and left behind only clues. Pluto is not just some curious little world. It might be the closest thing we have to a working model of what our own planet's sky looked like before life ever began. Now, the third Webb discovery is the one that honestly unsettles people the most, because it turns out Pluto has been slowly bleeding into space for billions of years. Methane and other light molecules keep drifting up through its thin atmosphere. They slip past Pluto's weak gravity, and they leak out into the darkness. Scientists already suspected this, but there was one huge mystery hanging over it. Where was all that escaping material going? It was not just vanishing, something was catching it, and that something turned out to be Charon. Charon is Pluto's largest moon. It is a battered ball of ice about 750 miles wide, orbiting so close to Pluto that the two of them almost dance as partners. Most of Charon looks pretty ordinary. Ancient water ice, lots of craters, nothing wild, except for its poles. Charon's poles are stained a deep, dark reddish brown, almost like rust. Nothing else on the moon looks anything like it. For years, scientists suspected that stain had something to do with Pluto. Here's how it actually works, and it is honestly beautiful in a strange way. Charon is tilted as it orbits along with Pluto. Because of that tilt, its northern pole is plunged into complete darkness for decades at a time. No sunlight at all. That turns the pole into what scientists call a cold trap. Any methane escaping from Pluto that drifts across space and happens to reach Charon's dark pole simply freezes onto the surface. It cannot stay a gas. There is no warmth to keep it floating. So it settles, it piles up, year after year, decade after decade. Then, eventually, sunlight returns to that pole, but sunlight here does not just melt the methane away. Instead, ultraviolet rays and cosmic radiation smash the frozen methane molecules apart and rebuild them into heavier, redder, more complex compounds. Those compounds are locked in for good. They cannot escape. They stain the pole forever. So Pluto is quite literally painting its own moon. Two worlds locked together in a slow, invisible exchange of atmosphere and color, running quietly for longer than we can even measure. A 2016 study confirmed the mechanism, and Webb has helped researchers see even more of the chemistry involved. Charon had one more surprise up its sleeve, too. In October 2024, a team led by Sylvia Protopapa at the Southwest Research Institute used Webb data to confirm two frozen compounds: frozen carbon dioxide and frozen hydrogen peroxide. Yes, the same hydrogen peroxide people pour on cuts and scrapes. According to the research, the carbon dioxide most likely came from deep underground, exposed by ancient impact craters. And the hydrogen peroxide seems to have formed from years and years of radiation, slowly rearranging Charon's water ice into something new. So even Charon, a moon that used to look plain and boring, keeps proving to be more chemically alive and complicated than anyone ever gave it credit for. Let me stop the story here for a moment, because I want to be real with you. If you're enjoying this, share this video with just one friend who loves science. That one share does more for a small channel like this than you could imagine. It tells YouTube this content matters, and it lets more curious people find it. All right, back to Pluto. I want to paint you a picture of what it would actually feel like to stand there. Because the truth is stranger than any movie. Imagine your boots touching the surface of Pluto for the first time. Your first instinct would be to look up at the sun, but the sun would not look like a sun at all. It would just be an extremely bright dot, smaller than the head of a pin held at arm's length. It would give off no warmth, no glare, no comfort. Around that tiny bright point, the sky would sit in a permanent grayish-blue gloom. Not day, not night. Just a hazy in-between that never changes. The ground under your feet would not feel like ice from a rink or a mountain. At nearly 400 degrees below zero, water ice loses everything you know about ice. It stops being slippery. It becomes as hard as stone. Hit it with something metal, and it would almost ring like a bell. The atmosphere around you would be so thin, about 100,000 times thinner than Earth's, that it would offer nothing to breathe. But you would not die from the lack of air first. The cold would reach through your suit almost instantly and freeze exposed skin before the air pressure ever became your biggest problem. And then, hanging overhead in the sky would be Charon. Not moving, not rising, not setting, just sitting there, fixed in one exact spot forever. Because Pluto and Charon are so close in size, they do not orbit each other the way Earth orbits the moon. Instead, they orbit an empty point in space between them, locked together so tightly that each one always shows the same face to the other. A quiet, endless standoff between two worlds that have been staring at each other for billions of years. And the surface itself would show you things no place in the solar system has ever shown before. In a region called Tartarus Dorsa, there are tall, jagged blades of ice, some of them reaching more than 1,500 feet high, made of frozen methane, arranged in long parallel rows like the teeth of some enormous ancient comb. Similar shapes exist on Earth in some high-altitude deserts. They are called penitentes, and they are usually smaller than a person. On Pluto, these blades appear to be enormous, and a 2025 analysis of the original New Horizons data suggests they might wrap around as much as 60% of Pluto's equator, a ring of frozen fangs circling an entire world. Nearby, a huge dark region roughly the size of Alaska stretches across the equator. It is stained a deep reddish black from tholin particles piling up thickest on some of the oldest terrain. And just south of the famous pale, heart-shaped plain, there are two mountains that scientists still cannot fully explain. One stands 13,000 feet tall, the other close to 20,000 feet. Both have deep pits at the top. Both are surrounded by fractures and lumpy, uneven slopes that look eerily like cooled lava flows. Except there is no lava on Pluto, no molten rock. So if these are what they look like, they are cryovolcanoes. Volcanoes that once erupted not with fire and stone, but with a thick slurry of water, ammonia, and methane. Scientists still argue over exactly how they formed, but every possibility points to the same truth. Something inside Pluto was warm enough to force liquid all the way up to the surface. And that thought leads to what might be the strangest possibility of all, a hidden ocean. Beneath Pluto's icy shell, roughly 100 miles deep, scientists believe there may be liquid water, kept liquid by the slow radioactive decay of elements inside Pluto's rocky core. Cracks and ridges on Pluto's surface line up in exactly the way you would expect if a huge layer of liquid was shifting. And that famous heart-shaped plain sits right above what looks like a gravity anomaly, a spot where something heavier and denser than the surrounding ice seems to be concentrated below. This matters because similar hidden oceans are suspected under the icy skins of Europa and Enceladus. If tiny Pluto is hiding one too, it suggests buried oceans might be the rule, not the exception. If Pluto's ocean actually exists, it has been sealed away for billions of years, no sunlight ever reaching it, no radiation touching it, just endless cold pressure and isolated chemistry. Right now, we have absolutely no way to know for sure. There is no lander planned for Pluto, no orbiter approved, no mission funded, because a trip to Pluto takes almost a decade. So for now, Webb is the only tool we have. And every few months, when Pluto swings back into its field of view, Webb quietly gathers another slice of data, and the picture gets stranger. Pluto sits inside a massive region called the Kuiper Belt, a vast freezing ring of icy debris just past Neptune. Hundreds of thousands of objects wider than 60 kilometers live there. Beyond even the Kuiper Belt lies something even more mysterious, the Oort cloud, a theorized giant shell of icy bodies, possibly holding another trillion frozen worlds floating in the dark. The Kuiper Belt is hundreds of times bigger than the asteroid belt between Mars and Jupiter, but it is almost completely unexplored. Only one spacecraft has ever gone deep enough to photograph it. So think about what Webb just proved. Tiny Pluto is cooling itself with its own atmospheric haze. It is leaking its air onto a moon and painting that moon red. It is running organic chemistry that mirrors the early conditions of life on Earth. And it might be hiding an ancient buried ocean that no one on this planet will see in our lifetime. If one small dwarf planet, once dismissed and voted out of the Planet Club, was carrying all of this inside it, then what are the other worlds out there hiding? Pluto is special because it is close enough for our instruments to see. Almost everything else in that huge frozen region beyond Neptune is still out there in the dark, unknown. Pluto was never the sad little dead end of our solar system. In fact, one vote in 2006 might have been one of the most misleading things ever done in modern astronomy. The more we look at Pluto, the more it seems to be the doorway to a much bigger, much stranger, much more alive part of space that we barely understand. Trillions of worlds waiting in the cold, barely glimpsed, barely studied, barely imagined. And Pluto is the one quietly showing us that everything we thought we knew was probably wrong. If you like stories like this one, rooted in real research and the work of figuring out what is out there, then hit that subscribe button and turn on the notification bell. Webb is still watching Pluto. It is still checking in every few months. And there is a very good chance that the next round of data will hand us another mystery, even stranger than this one. Thank you for staying with me all the way to the end. I really do appreciate it, and I will see you in the next one.